In the previous section, we looked at how two liquids are soluble in each other if they have similar intermolecular forces. And now what we want to do is look at why do ionic solids dissolve in water. And this is kind of tricky because we have previously stated that ionic solids have ionic intermolecular forces, which we know are very, very strong. And water has the strongest intermolecular force of hydrogen bonding. So how do these two interreact to allow ionic solids to dissolve in water? And the answer is that when ionic compounds dissolve in water, there is a special interreaction, so a special intermolecular force that we haven't talked about that yet. And this comes from the idea that ionic compounds are electrolytes. So when we put them into solution, they dissociate into positive and negatively charged parts. And the idea is water will interact differently with these ionic species. What happens is the fact that water actually has a dipole. It has a positive and negatively charged side. And when the ions in solution, so like Na+, they get surrounded by the negative side of multiple water molecules, and the Cl- gets surrounded by multiple waters which have a positive side. And with these interreactions, so the interactions of an ion with the dipole moment inside of water is called an ion-dipole intermolecular force. And this is actually considered to be the strongest intermolecular force. So the reason why ionic solids dissolve in water is because they actually form a more stable situation. They form stronger intermolecular forces, and this intermolecular force, the ion-dipole intermolecular force, is stronger than the regular ionic intermolecular force. So it's thermodynamically favorable for the ions to dissolve in solution. So here's kind of a rough example of what we're talking about. So water does have a dipole. Typically when we talk about water, we talk about the fact that its strongest intermolecular force is hydrogen bonding, but water actually does have a dipole. Oxygen's electronegative compared to hydrogen's, and the electrons in this molecule are pulled closer to the oxygen and away from the hydrogens. This gives the oxygen side of the water a partial negative charge, and the hydrogen side of the molecule a partial positive charge. Here we're starting with sodium chloride in itself. It has an ionic intermolecular force, but when we dissolve it in water, it breaks up into Na+ and Cl-. And what happens is this Na+ gets surrounded by multiple waters, and it interacts with the negatively charged side of each water molecule. So because we can get many water molecules, so more than just 4 here, to interreact with the sodium, that actually forms a stronger intermolecular force. So the same thing happens with the Cl- or the negatively charged species. This interreacts with the positive side of the waters, and this also creates an ion-dipole intermolecular force. So because there's so many of these waters surrounding these ions, they actually form a more stable situation. So in this, when we take a ionic solid and dissolve it in water, we end up forming an ion-dipole intermolecular force, which is stronger typically than the ionic intermolecular force that the solid originally had. So what happens overall that we are going from a less stable to a more stable situation, and that the intermolecular forces that we have with the waters and the Na+ and the Cl- are actually more stable than the intermolecular forces we had with the starting material. Because we're going from a less stable to a more stable environment, often when we dissolve ionic solids, there is energy that's given off. So this energy that's given off when we hydrate ions, so when we dissolve ions in solution, is called an enthalpy of solvation. So there's actually some thermodynamics that occur just in taking ionic solids and dissolving them in water. It's something that you can actually measure. And most of the time, this is an exothermic process, but not all the time. So there are some salts that are actually endothermic, that absorb energy from the surroundings when you dissolve it inside of water. But the idea is this is another type of a phase transition. When we were talking about the enthalpy of phase transitions, you can also have an enthalpy of solvation. So we're taking an ionic solid and dissolving it in water.